hall. So this is K. Pushpa Rani, Associate Professor, Department of CSC, MLR Institute of Technology. So today we are going to discuss about the topic in discrete mathematics, equivalence implication. So what is the overview of this today's lecture is what is meant by equivalence implication. Now we need to verify whether the given preposition is equivalent or not, and we can understand that equivalence implication by taking some examples. Now first of all, let us discuss about the equivalence implication, or it is the definition of equivalence implication. Two formulas A and B. A and B. So two formulas means what are the formulas of A, B? There are two compound statements P or Q, or P and Q. This is the first statement formula. This is the second statement formula. Okay. So there are A and B are said to be. That means what is A, P or Q? What is B, P and Q? Are said to be equivalent to each other if and only if A is equivalent to B. A is equivalent to B. How can we say that the two prepositions are equivalent? So this equivalent is denoted by taking the biconditional statement. This is the symbol to denoting the equal. Sometimes we can use 3 equals to denoting the equality between the two prepositions. Now let us understand by taking some more techniques whether the two prepositions are equivalent or not. So what is the rules we have to follow to check whether the two prepositions are equivalent or not? This is also called as logical equivalence, or it is a equivalence implication. Logical equivalence means the relationship between two statements that have the same truth value in every possible scenario. That means P or Q produces true, true, false. And P and Q also produces true, true, false. For every combination, statement formula A and statement formula B producing the same truth value for any combinations of input, then A and B are said to be equivalent, or it is a logical equivalence. That may be true or it is a false, but it returns as the same values in the truth table. Formula A and formula B should produce the same values in the truth table. Then it is called as a equivalence implication, or we can call it as a logical equivalence. So I told that it is denoted by using some symbol called biconditional statement, or we can use 3 equals to denoting the two statements are said to be logical equivalent. So there are two methods to find whether the two prepositions or two formulas are equivalent or not. So in this lecture we are going to discuss about truth table method. In the next video we are going to discuss about by applying laws. So we know the procedure for the truth table method. Let us discuss by using truth table we need to verify whether the two statement formulas are equivalent or not. So in the case of truth table, it is one of the tool to determine whether the two prepositions are equivalent or not. Well, how to say that? We can say that it is two logically equivalent means we can write all the possible combinations of true value in the truth table, and we need to compare the last column of the truth table in two statement formulas, and if both are matched in every case, then the statements are said to be logically equivalent. So what is the first method? It is we need to construct the truth table, okay, for all the combinations of given inputs, and compare the last column of the truth table. In every case, it consisting of the same truth value in both prepositions. We can say that these are logically equivalent. And one more condition for the logical equivalent means the entire preposition is a tautology, then it is a logical equivalent. We can understand the second statement by taking an example. Okay, check whether the two statements are logical equivalent or not. First one is a P implies Q is equivalent to negation P or Q. We need to check these two prepositions are equivalent or not. First thing is there are two conditions to check whether they are equivalent or not. First thing is P or Q. P implies Q is the statement formula A. Negation P or Q is the statement formula B. So, A equivalent to B means it consisting of the same truth value. That is the first condition. Second condition is P conditional Q, then negation P conditional Q, both are returns as a total. So, we need to apply the biconditional for these two prepositions. If it returns as a tautology, then the two statements are said to be logically equivalent. Let us discuss by taking an example. P or Q. Okay, P, there are two prepositions by default consisting of 4 rows in the truth table. P conditional Q. P conditional Q returns as a false if the first statement is true, second statement is false, then only it returns as a false. For the remaining cases, it returns as a true value. What are the combination? True, false, true, true. Okay, that is the 4 combination. Negation P or Q. So, take the negation P, opposite of P. That means true is there, we can write it as a false. True is there, we can write it as a false. False is there, true, then true. Negation P or Q. False, true, true only. Then after that false, false, false only. True, true, true only. True, false, true only. So here P or Q is the formula A. P implies Q is state. Negation P or Q is B. Here the combinations are true, false, true, false. Here it is a true, false, true, true. So both the combinations are same. Both combinations are same. Then A is equivalent to B. A is equivalent to B. And what are the one more condition I told just now is A or B. A implies B returns as a tautology. Then it is a logical equivalent. That means we need to take A equivalent to B. What is the biconditional statement? Biconditional statement returns both values are same. It returns as a true. That means true, false, true, 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 false, false, also true. For the remaining cases, it returns as a false value. That means take A or B. Now I will clear the screen and I will explain. So take this one is A, this one is B. Okay, then A equivalent to B. Equivalent means biconditional statement. Biconditional statement returns both are true or both are false. It returns as a true. For the remaining cases, it returns as a false value only. So, A, P or Q, then P implies Q. True, true. It returns as a true. False, false. It returns as a true. True, true. Returns as a true. True, true, true. The final column of the truth table for the entire equivalent is a tautology. That is the second condition to verify whether the two prepositions are logical equivalent or not. Consider the second example to check whether the given prepositions are equivalent or not. We need to prove P or Q is equivalent to negation, negation P and negation Q. So, first take negation P. Negation P is the opposite of P. True, true, false, 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 true, true. Negation Q is opposite of Q. True, false. Then we take false, true. Then true, false, false, true. That is the negation Q. Then first apply the innermost preposition. Innermost preposition is, we know what is negation P. We know what is negation Q. Apply and in between two. False, false, false only. Then false, true. That means false only. True, false is false only. True, true, true only. We know that negation. Again apply the negation for the same preposition. Write opposite of the values. False is there. Take negation means it becomes true. Again false is there. Again false is there. Take the negation. False, true. Again false, then true. Again false, take true. Negation. True is there. False. After that we need to check with the P or Q. P or Q returns false if both prepositions are false. True, true, true only. True, false, true only. false, true, true only, false, false, false only. Here observe this column and this column. Here the P or Q is equivalent because it produces the same combinations. That means true, true. It also true, 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 false. It produces the same combination. So these two statements are said to be logical equivalent. And I already told that one more condition, the entire preposition should produce the tautology. Then also we can say that both are logical equivalent. So what is the first preposition? P or Q. This is considered as a 1 or it is a. Second preposition is equivalent, means we can use conditional, biconditional statement. A, biconditional B. So biconditional statement returns false if any one of the preposition is false. If the true values are same, it returns as a true. Here it is a true, true, true only, true, true, again true only, true, true, true only, then false, false, also true. The final column of the truth table is true. Then we can say that the given preposition is logically equivalent. The first condition is LHS and RHS should produce us the same value. Then we can say that it is a logical equivalent. And LHS by conditional RHS returns as a tautology. Then we can say that the two prepositions are said to be logical equivalent. So what we have discussed now. So what is meant by equivalence implication? What is the definition? Now we'll take some example how to check whether the two prepositions are logical equivalent or not. Thank you.